So this is going to be part 2 of section 2.4. There's a better than not chance that there's going to be a part 3. It'll be really short, but the stuff right at the end of this section, if I put it at the end of this video, you might not watch it, and I think it sneaks on the test. Before we go into this part, which is kind of doing the derivatives of logarithms, we have to remember some things about reducing fractions when you can and can't reduce. If there's a plus or a minus between a number and a letter, you can't reduce unless they're identical copies of that kind of factor in both the numerator and the denominator. So this fraction right here, you're not allowed to reduce the x's. Once there's a plus or minus between a number and a letter, here you can't reduce. If there's only straight multiplication between the numbers and the letters, then it's okay to reduce. So there's a lot of students, when we start doing derivatives in this section, that and don't remember intermediate algebra as well as they need to, and they might be tempted to reduce something like this. However, something like this, I'll try to make up something like 8x plus 16 over 6x plus 12. The way it's written, it can't reduce specifically, because if there's a plus or minus between a number and a letter, you can only reduce if the factor is identical. This problem, there was nothing to do to make it so it could be reduced. This problem, if I, one parentheses common factor out a common factor of an 8 in the numerator and a 6 in the denominator, then I can produce something that is doubly reducible. If I factor out an 8 in the numerator, I'd have to divide both the 8 and the 16 by 8, and I'd be left with an x plus 2. If I factor out a 6 from the denominator, I'd have to divide the 6 and the 12 by 6 and get another x plus 2. Now I have identical factors with plus signs between them. Those can cancel. And single numbers in front of parentheses can cancel with single numbers in front of parentheses. So the x plus 2's will cancel, and both the 8 and the 6 are divisible by 2, and that will reduce to 4/3. So that's just a quick review of reducing fractions. There's no addition or subtraction between numbers and the letters. Then you can reduce any letter with any letter, any number that reduces with any number. But if there's pluses or minus between numbers and letters, you can only reduce if there's an exact copy. And sometimes when the problem starts off, it doesn't look like there's an exact copy that can be canceled. Sometimes you can factor and make that happen. The other thing that we're going to have to know a little bit about are the parts of logarithms. This I would read as a log base 2 of x minus 3. And in this particular logarithm, the base is 2, and the argument is x minus 3. Sometimes we'll write a logarithm like this, the logarithm of, how about like x squared. In this logarithm, the base isn't written, but it's assumed to be a 10. So if you see the word log and you don't see a base, the base is assumed to be 10. And here the argument, which I put in a parentheses, but more often than not I don't use the parentheses, but the argument is x squared. And lastly, if we had something like this, the ln of 2x minus 7, here, if you see in ln, the base is assumed to be e, and here then the argument is 2x minus 7. So if the base is other than 10 or e, the base is going to be written. So any base other than 10, or e will be written. Log without a base written is assumed to be base 10. ln is supposed to be base e, for what it's worth. So those things we kind of have to remember in order to be able to do this section, which is the derivative of logarithms. And logarithm derivatives are fairly easy. They're in some sense surprising because the derivative of a logarithm doesn't have a log in it. But if I give you just a generic function, y equals the log base 5 of x squared plus 6x plus 3. To do the derivative of a logarithm, you have to be able to identify the base. Let me put a coefficient in front of it too. Let me do a 7 in front of there. I need to figure out the base, the coefficient, the argument, and the derivative of the argument. So all 4 of these pieces are needed to do the derivative of a logarithm. In this particular problem, I put a coefficient of 7. If there wasn't a number there, there'd be a coefficient of 1. I can kind of ignore it. If there was an x to the left of the logarithm, I'd need to use the product rule. But here in this problem, the coefficient is 7. The base is 5. The argument is x squared plus 6x plus 3, and the derivative of the argument, the derivative of x squared is 2x, the derivative of 6x is 6, the derivative of 3 is 0. The derivative of a logarithm is going to be 1 over the natural log of the base times the coefficient times the derivative of the argument can't write it all here, derivative of the argument over the argument. This is kind of a formula for the derivative of a generic logarithm. And oh gosh, how about let me clean it up a little bit, because it's always going to simplify. Let me clean it up to be this. How about just this? Forget this 1 over part. Let me write it as the coefficient, sorry about that, coefficient times the derivative of the argument divided by the natural log of the base times the argument. I think that's probably a nicer form for the derivative. They're both correct, but this one would probably make a nicer answer. So for this particular problem, if I want to find the derivative, in the numerator, I need the coefficient and the derivative of the argument. So if I'm finding the derivative of this logarithm, it has a coefficient. That's going to go in the numerator of my derivative. The derivative of the argument is going to go next to it in the numerator. In the denominator, I get the natural log of the base, so more than just the base, the natural log of the base, and the base is 5. And then times the argument, and the argument is x squared plus 6x plus 3. An x squared plus 6x plus 3 can only cancel with an x squared plus 6x plus 3 on the opposite side of the fraction, which I don't have. This is an adequate derivative. This numerator, I could pull out a common factor of a 2 from the 2x plus 6 and multiply that by the 7 and get the derivative equals to 14 times x plus 3 over the natural log of 5 times x squared plus 6x plus 3. That's not going to reduce because an x plus 3 can only cancel with an x plus 3. Common factors in front of parentheses can cancel with each other, but I can't cancel an integer with a natural log. So that would be the derivative of that. And now I'm just going to kind of push through the section and see what I can do with it. if I want to do the derivative of 34 or 33, I'll do 34. The coefficient, the number in front of the logarithm, is 1. The base, because it's an ln, is e. The argument is the 2x. And the derivative of the argument is just 2, because the derivative of 2x is 2. And so for the derivative, it's going to be the coefficient times the derivative of the argument divided by the natural log of the base times the argument. So if I want to be super detailed here and write a couple things that I probably wouldn't normally write, I'm going to do that. I'm going to write the coefficient that's assumed to be 1 times the derivative of the argument, which is 2, divided by the natural log of the base, which is the natural log of e, times the argument, which is 2x. That's the derivative. Now I'm going to clean it up. It comes up a decent amount in our class that the natural log of e, so if I did a natural log button and then second and divide for e, comes up a lot in our class that the natural log of e is 1. And so when the base is e, or when I have an ln, I usually don't put this piece in the denominator because it's equal to 1. So this is really, the denominator is really 1 times 2x, because the natural log of e is 1. The numerator is 1 times 2, which is 2. So this whole derivative comes out to be 2 over 2x. In this fraction, I don't have any adding or subtracting, so I'm allowed to cancel the 2's. When I cancel the 2's, they turn into 1's. I can't write a fraction without a numerator, so I need to leave the 1 behind in the numerator. And the derivative for number 34 is just going to be 1 over x. If I was doing 36, I'm going to say the coefficient is 1. It's a log without a base written, so the base is 10. The argument is 2x, and the derivative of that 2x, the derivative of the argument, is just 2. So the derivative is going to equal to the coefficient times the derivative of the argument over the natural log of the base, and that's not equal to 1, times the argument. So the derivative, y prime, is going to equal the coefficient 1 times the derivative of the argument 2 divided by the natural log of the base, ln of 10, times the argument 2x. In the numerator, I can multiply the 1 by 2 and get 2. In the denominator, I have the ln of 10 times 2x. There isn't any adding or subtracting in either the numerator or the denominator, so I can cancel the 2's. And just to show you that the ln of 10 is just a nasty decimal, so I'm just going to leave the symbol ln of 10 in my answer, but I am going to cancel out the 2's. And when I cancel out the 2's, I'm left with 1 in the numerator, and then the ln of 10 times x in the denominator, and that would be my derivative for 36. All right, so for 38, there's no number to the left of the logarithm, so the coefficient is 1. It's an ln, so the base is e. The argument is x squared minus 5x. And the derivative of the argument is 2x minus 5. When I go to write my derivative down, again, it's the coefficient times the derivative of the argument over the natural log of the base times the argument. And if you're getting good, you're not going to write down the things that are equal to 1. The coefficient of 1 I probably shouldn't write down. The derivative of the argument I do need to write down. If I didn't write down the 1, I wouldn't put it in a parentheses. The natural log of the base is the natural log of e. That's equal to 1. I shouldn't write it down. And the argument is x squared minus 5x. So if I was doing this, my first step would say this. It would say 2x minus 5 over x squared minus 5x, specifically because the numerator, the 1, anything times 1 is itself, and in the denominator, the natural log of e is 1. And I know that I can skip the pieces that are equivalent to 1. So skip that and skip that because they're equal to 1. This is an okay answer. The only way this would reduce is if I can factor and produce an x, 2x minus 5. When I go to factor the denominator by pulling out a common factor of an x, I'm not left with an 2x minus 5. So this can reduce, but it can't cancel, because when I pull out a common factor of x, because both terms in the denominator have an x, when I take an x away from each, I'm left with x minus 5 in a parentheses, and that won't cancel with a 2x minus 5. When you have adding or subtracting between numbers and letters, you can only cancel if they're identical between them. All right, so 40, let me just do this quicker. My coefficient is 1. My base is 4. My argument is x squared minus 5x. And the derivative of the argument is 2x minus 5. I go to do the derivative. It's the coefficient 1 times the derivative of the argument, 2x minus 5, over the natural log of the base. That's not equal to 1. That's equal to an ugly decimal, so I'm just going to leave it in my answer, times the argument. In the numerator, I'm going to not write the 1, and I probably shouldn't have written the 1 anyways. It's not needed. And in the denominator, I'd probably pull out a common factor of x, just like I did in the last problem. That's probably where I'd stop for an answer. It just seems so blurry right now. The tech guy on campus fixed my this document camera because it wasn't working right earlier today, and it just seems so blurry. I tried to unblur it, so hopefully this is all readable. I'm pulling out a different pen to see if this is going to help at all. So for 42, the coefficient is 1, so I probably shouldn't put it in my answer. The base is e, and when I put the ln of e down, that's equal to 1. I probably shouldn't include that in my answer. The argument is x plus 5 cubed, and when I go to do the derivative of the argument, because it's a parentheses with an exponent, I need to use the chain rule. Chain rule says to bring the exponent out in front of the parentheses, leave yourself some room, lower the exponent by 1, and inside that parentheses where I left myself some room, I write the derivative of each term that's inside the parentheses. So parentheses with exponents are chain rule. Bring the exponent out front, lower the exponent by 1, keep the contents of the parentheses the same, and then in the gap between the exponent and the original parentheses, put the derivative of each term inside the parentheses. The first term inside the parentheses is an x to the first power term. The derivative of any x to the first power term is the number to the left of the x. There's an implied 1 there. So the derivative of 1x is 1. The second term is a constant. It has a derivative of 0. So the derivative of the argument is going to be 3 times x plus 5 squared. When I go to write my derivative down, I'm going to use the prime symbol. In the numerator, I'm not going to include the coefficient because that's equal to 1. In the denominator, I'm supposed to put the ln of the base, but that's also equal to 1. So I'm not going to show that either because those two pieces are equal to 1. They're not necessary to write down. You can write them down, but they're going to turn into 1 and go away anyways. So I'm not going to show those two parts. I'm just going to show in the numerator the derivative of the argument, and in the denominator the argument itself. Now I need to reduce this. If I want to emphasize, what I have is x plus 5 squared in the numerator, which is really 2x plus 5 being multiplied, and x plus 5 cubed in the denominator, which is really 3x plus 5s being multiplied, I could cancel 2 of the x plus 5s and leave myself a single x plus 5 in the denominator. The other way to reduce this is to subtract the exponents and leave the factor where the bigger exponent is. 3 minus 2 is 1. I should be left with an x plus 5 to the first power in the denominator. So technically, the derivative is this. What if I subtract the exponents? But I don't need to write a parentheses when the exponent is 1. I could just drop both the parentheses and the exponent, and that would be probably a fine answer for 42. All right, let's do 43 together. So for 43, the coefficient is 1. I won't worry about it. The base is 2. I need to worry about it. The argument is x minus 3 to the 4th, and the derivative of the argument, because it's a parentheses with an exponent, I need to use the chain rule. I'll bring the exponent out front, leave myself some space, leave the contents of the parentheses the same, lower the exponent by 1. Where I have that space, I'm going to write the derivative of each term inside the parentheses. A single x has a derivative of the number that's implied in front of the x, which is 1. The minus 3 has a derivative of 0 because it doesn't have a letter. So this is going to just be 4 times x minus 3 cubed. When I go to write down my derivative, I'm going to write f prime of x for problem 43. I'm not going to write the coefficient because that's not a 1, but I am going to write the derivative of the argument, and that's going to be 4 times x minus 3 cubed. In the denominator, I get the natural log of the base times the argument. I can't cancel a natural log with a 4. So those will just, the 4 and the natural log of 2 will hang out. And for these pieces with the parentheses, I'm going to subtract the exponents and get x minus 3 to the first power in the denominator. So when you have common factors, you subtract the exponents, you leave the factor where the larger exponent is. And in this problem, I need the parentheses because of that multiplication of the natural log of 2 that's down there. I don't need to write the exponent of 1 that's implied. So this is a perfectly good answer for problem 43, other than I probably shouldn't write the exponent of 1. Let's skip 45 and 46. I don't want to deal with these fraction exponents right now. That would come out from a radical. They're not on the test. They're not a big deal for the rest of the class, nor in 218. So let's just kind of punt on those. And now I'm into the world of product rule. Specifically because I have multiplication and both factors have an x, you have to use the product rule. So if I was doing problem, let's just do 47. If I was doing 47 with you, I'd have to say the first factor is 3x. The second factor is the ln of 5x. If there's multiplication and both factors have an x, you need to use the product rule. You separate the factors and then you write the derivative of each. So the derivative of the first factor is just going to be 3. It's an x to the first power term, so the derivative is just the number in front of the x. And for the derivative of the second factor, I need to know the coefficient there. The coefficient is 1. I won't need to worry about it. The base is e, and because the ln of e is equal to 1, I won't throw that down into the denominator either. The argument is 5x, and the derivative of the argument is just 5. When I go to write this derivative down, technically it's the coefficient times the derivative of the argument over the natural log of the base times the argument. Don't need to write a 1 there in the numerator because 1 times 5 is just 5. And in the denominator, the natural log of e is 1. So this is really 5 over 5x. I could cancel the 5's. They both turn into 1. I need to write the 1 in the numerator. So there is everything I need to use the product rule. And remember, the product rule is first factor times the derivative of the second plus the second times the derivative of the first. I think I just multiply this way and that way. So multiplying first factor times derivative of the second, I get 3x for the first factor. The derivative of the second is 1 over x plus second factor, ln of 5x, times the derivative of the first, which is 3. And I should probably write y prime equals, didn't sneak that in there. X times 1 over x is like 2 times 1/2. They cancel. X times 1 over x is 1. So these x's are going to cancel right there. And that piece is just going to be a 3. Now on either side of the plus sign, I have a 3 that I can treat as a common factor. And if I factor out a 3, the 3's turn into 1s. This 3 will turn into a 1. And I need to write it because I can't write nothing to the left of the plus sign. But after the plus sign, the 3 that turns into the 1, I don't need to have to write a 1 there because I still have the ln of 5x hanging around. So that would be a perfect derivative for problem 47. All right. Let's do 49 together, and then I'll not do the next one. We're getting closer to the end of this video. How many? Oh my gosh, I take that back. There's another 10 problems. So if we were doing 49 together, it's multiplication, both factors have an x, I need the product rule. So first factor, pause the video and give this a try. That would be the best thing to do. And second factor. The derivative of the first factor is easy. It's just the derivative of that minus 2 is 0. The derivative of that y is 1. For the second factor, the coefficient is 1. The base is e. The argument is 3y. The derivative of the argument is 3. When I go to write the derivative of it, I don't need to write the 1 in the numerator for the coefficient. I'll just write the derivative of the argument. And in the denominator, I don't need to write the natural log of the base because the natural log of e is 1. So I'm skipping the coefficient and the natural log of the base, doing the derivative of the argument, and then over the argument. So it's just derivative of the argument over the argument. The other two pieces are 1. The 3's are going to cancel. This is going to equal to 1 over y. So when I go to write my derivative for problem 49, it's going to be first factor y minus 2 times the derivative of the second factor, which is 1 over y. Instead of writing it after the parentheses, I'm going to put it before the parentheses, not that it matters, but I like it that way. And then second factor times the derivative of the first. This piece just turns into ln of 3y. If I wanted to clear the parentheses, which I kind of like to do, I'd multiply 1 over y times y, and I'd multiply 1 over y times minus 2. So if you want to clear the parentheses, which is kind of preferred, there isn't anything this complicated on the test, but for homework purposes, if you wanted to write something that's a little bit cleaner, I'd distribute the 1 over y through the parentheses. 1 over y times y is 1. And 1 over y times minus 2, I'm multiplying a positive times a negative, so I get a negative. And if you multiply a fraction by an integer, you just multiply the numerator by that integer. I think that's where I'd leave this. I'd clear that parentheses. There's definitely other things that I could do. Maybe in Math 220 I might do some of those other things, but boy, it's not important for us. This is way more than enough, and there isn't anything quite this complicated on the test. If you want to try 51, try it. If you don't want to try it, skip it. There isn't anything like it on the test. They're not important for the rest of the class, and oh, it's so much busy work. Let's move on to the last couple for this part of the video. Just have e's and ln's together. And that's not fun. I don't know whose is harder. I'm going to do 54. It's a division, so I need the quotient rule. The quotient rule, remember, it's the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. So in order to do 54, I need to know the new denominator, which is e to the x. I need to know the numerator, which is the ln of x. And technically, to do the derivative of an e, there's a long involved formula, but the shortcut for finding the derivative of an e, so just in case I didn't make it clear enough, the shortcut for an e derivative is just the derivative of the exponent times the e function unchanged. I kind of did it like, coefficient times the derivative of the exponent times the e function unchanged times the natural log of the base kind of thing. It had 4 pieces in it. We had like the coefficient. The coefficient is 1, so it's not needed, times the natural log of the base. The base is e, so the natural log of e is 1. So these pieces are both 1s for this case. So if you just have a naked e, its derivative is just the function, and to the left of the function, you write the derivative of the exponent. So to do the derivative of an e, although there's generally 4 pieces to the derivative of an exponential function, 2 of them are equal to 1, so we don't need to write them. I'm going to write the e function, and to the left of it, write the derivative of the exponent. That's just writing the derivative of x, and the derivative of x is just 1, because that's the number that's in front of the x, and it's a first power term. So the derivative of the denominator is also just e to the x. To do the derivative of the numerator, technically I need the coefficient is 1. Don't need to worry about that. The base is e, and the ln of e is equal to 1, so I don't need either of those 2 pieces in my answer. The argument is x, and the derivative of the argument is the derivative of x, which is just 1. Technically, the derivative is the coefficient of 1 times the derivative of the argument over the ln of the base times the argument. But coefficient is 1, I don't need to write it. Natural log of the base is the natural log of e, which is 1, don't need to write it. So when I go to write the derivative, I'm just going to do the derivative of the argument, which is 1, over the argument itself, which is x. That's the derivative of ln of x that I'm going to use. So the pieces I'm going to use, the denominator times the derivative of the, numerator, the derivative of the denominator, and the numerator. These are the 4 pieces I'm going to write down. So let me try to do this. Denominator, e to the x, times derivative of the numerator, 1 over x, minus numerator, natural log of x, times derivative of the denominator, e to the x, all over the denominator squared. And I should probably write f prime of x equals, and this is for problem 54. I don't know if your problem is harder or easier, it's just different. In the numerator, I'm going to pull out a common factor of e to the x, and I'm going to write this as f prime of x equals e to the x, and then inside the parentheses, I'm left with a 1 over x minus ln of x when I take an e to the x away from each piece. In the denominator, instead of writing e to the x with an exponent of 2, I'm going to write it twice as an e to the x. And now I'm going to cancel and cancel. And I'm not going to go any further than this. I'm going to say my answer to problem 54, the numerator is going to be 1 over x minus the natural log of x and the denominator is going to be e to the x. There's definitely things I can do to write that better. Nothing like this comes on the test, so I'd probably just leave it there. So give 53 a try. If you can't match up with my solution, ask me in class. If it completely frustrates you, give it a try and just stop. It's not good. It's more complicated than we need. Let me do 55 with you and not do 56. Fraction, so I need the quotient rule. The denominator is natural log of t. The numerator is 3t plus 4. To do the derivative of the denominator, technically, I need the coefficient. It's 1, so I don't write it. It's an ln, so the base is e. And since the natural log of e is 1, I probably shouldn't write that part. The argument is t, and the derivative of t is just 1, the number in front of the t. If I was doing the derivative properly, I'd go coefficient times derivative of the argument over the natural log of the base times the argument. But the coefficient is 1, doesn't need to be written. Natural log of the base is equal to 1, doesn't need to be written. So I'm just going to write the derivative of the argument, which is 1, over the argument, which is t. So I'm going to need the denominator, the derivative of the denominator here, the numerator, and that's an easy deriv. The derivative of the numerator is just 3. The first term is the first power term of the derivative, its coefficient. Second term is a constant, has a derivative of 0. So those 4 pieces are going to go in my answer for problem 55. So I'm going to go the derivative equals the denominator times the derivative of the numerator. The denominator is the natural log of t. The derivative of the numerator is 3. Let me write it first as opposed to after the natural log. It just looks more natural that way. Minus the numerator times the derivative of the denominator. Numerator is 3t plus 4. I'm going to write the derivative of the denominator to the left of it as opposed to after it. But this is denominator derivative of the numerator written backwards. Numerator derivative of the denominator written backwards, all over the denominator squared. So all over the denominator squared. Can't cancel ln of t's here because in order to cancel an ln of t, there needs to be like a single common factor of ln of t. If I wanted to clean this up, I'd probably clean out this parentheses by multiplying negative 1 over t times 3t and negative 1 over t times 4. And I would leave this as the derivative is 3 times the natural log of t minus this multiplication right here. The t's cancel, negative 1 times 3 is negative 3. Next, when I'm multiplying a fraction by an integer, I'm just going to multiply the negative 1 and 4 and get minus 4 over t. I have this double negative that I wrote down wrong here. It should just be minus like that, and that should be minus 4 over t. And then the denominator, it's not going to cancel because I don't have a common factor of an ln of t in the numerator. I'd probably just leave the denominator with that parentheses. A horrid problem, but that's kind of is what it is. Oh my gosh. I still have like 5 problems left to do. Let's do like 2 of them. And, which are the 2 to do? Well, no, I have 2 problems for this part of the video. Let's just do 1 of them. So let's skip 59 and 60. You can give them a try if you just like these, but you can skip them. Let me do 57 with you. Again, this is a little more complicated than anything that I probably should have put in the material. The simplifying part is problem. So this is multiplication in 57, so I need the product rule. First factor is e to the x squared. Second factor is ln of 5x plus 1. I'm going to double shortcut my derivatives. The derivative of the first factor, it's an e function without a coefficient. The shortcut for finding the derivative of an e function without the coefficient is just to write the e function down, and to the left of it, write the derivative of the exponent. The derivative of the exponent is x squared. The shortcut for finding the ln derivative that doesn't have a coefficient, because the coefficient is 1 and the thing that goes in the base is equal to 1, is just has the argument and the derivative of the argument. The other two pieces are equal to 1. The argument is 5x plus 1. The derivative of the argument is 5, because the derivative of 5x is 5. The derivative is 1 is 0. And so for the derivative of the second, it's going to be 5 over 5x plus 1. You can't cancel the 5s. You can only cancel when there's a 5x plus 1 can only cancel with another 5x plus 1. Well, this is absurd. So when I go to write this down, first factor times derivative of the second. So I'm going to write f prime of x equals first factor times derivative of the second plus second factor times the derivative of the first and I like common factors. There's a common factor of e to the x squared, so I just simply use the pieces. First times the derivative of the second, second times the derivative of the first. Now I'm going to plot that common factor of e to the x squared. Make a big parentheses, and for the first piece it's going to be 5 over 5x plus 1. The second piece I have after the plus is the ln of 5x plus 1 times 2x. Fast, probably too fast, but I didn't want to, the video's getting so long, I didn't want to go further with this. That's the derivative. If the problem's in the 50s where I started using the quotient rule with the e's and the ln's combined, or the product rule with the e's and the ln's combined, if those didn't really feel good, it's okay. Those won't make it on to any test. They're not going to be a big deal for the rest of our class, nor in 218. So I'll pause the video, then I'll do a part 3 here in a bit.